Hey, my name is Thomas and this is day 19 of 100 Days of Code in IoT Challenge. Today I'm gonna be downloading the file from the internet on ESP8266 over HTTP protocol and storing it in device's flash memory. Today there's not gonna be any other hardware parts except for the ESP8266 itself, so I'm just gonna move to the code straight away. So that's the latest example from yesterday's video on the file system with the use of buffer. And what I'm gonna do is to remove most of it. Let's start fresh. So let's remove the setup and let's remove everything in the loop. Yeah, let's just remove everything in the loop. So we just have this bit and even the file name is not needed now. So we just have the serial begin to start the communication on the serial port and the delay at the beginning for the IDE to catch up with the information sent from the device over serial port. Okay, one more thing for those who haven't watched the yesterday's video. Yeah, apart from the monitor speed, obviously, that needs to be added to PlatformIO.ini, and the same value has to be here. We need the board build.file system to equal to little fs. That is to set the default file system on the device to little fs instead of the default instead of SPIFs, which is a default one for PlatformIO for backwards compatibility reasons. So this is what you need to do at the beginning. And also, before I write the first line of code, what I need to do is to add a lib directory to the gitignore, and then I'm going to change directory to lib. Actually, I'm already in this directory, but you would probably start from the file system, right? So I need to go to lib, and inside the lib, I want to clone my library, my core library I've built. There was a video from the day 15, right? The long refactoring session, and I've built some tools to deal with Wi-Fi, with HTTP client, HTTPS, actually it was HTTPS client, and timer and even dispatcher. This is gonna be useful today. So I'm cloning it into the core directory. This is important. Okay, done. So yeah, I've got it pulled here, and now we can start. Right, so the goal first, let me just make it more visible. Maybe this is too big, but yeah, like that. So the goal today is going to be, first, we're going to download a small file from the internet, and then we're going to display the contents of the file. Right, so again, I'm starting from the simplest example. And apart from the little fs, I need bunch of includes, which is, I need the Wi-Fi multi, right? We need internet connection to be able to download something from the internet. So that's one thing. Another thing is going to be the even dispatcher from my library, timer. These are just the dependencies on the Wi-Fi manager itself, right? So these are required includes, and I'm simply gonna create instances of those, right? So that's gonna be dispatcher, timer, and we also need ESP8266 Wi-Fi multi, And also I need to define my Wi-Fi network SSID and password. Because that needs to be passed to the Wi-Fi manager. So I'm gonna call it, this variable is gonna be called Wi-Fi manager. And I think the first one that is required here is Wi-Fi multi-pointer, dispatcher timer. So Wi-Fi multi, dispatcher, timer, and then I think it is SSID and password. Okay. So now with the instance of Wi-Fi manager, we can essentially connect to Wi-Fi in a non-blocking way, right? I really recommend watching this video when I've built those classes so you can understand how these classes work. I mean, it's a bit long, but it is quite interesting how to build a non-blocking code on ESP. Okay, so that's one thing, and then let me show you what sort of files we're gonna be downloading. So I prepared an S3 bucket. I called it 100 days of code, and this is just index.html file here. I've got two files. One is small, and the second one is a big one. This is just HTTP 1.1 specification, so it's much bigger. We're going to start from the small one. So this is the one I'm going to download. It could be potentially used as a schedule for the temperatures, right? You remember the temperature controlled relay project, and this is how we could pull some data on the schedule on the temperatures, right? So something like, what the temperature should be within the time range, and this being the time range and this being temperature, right? So it's just an example that could be used. But yeah, it's an example of small file, right? Because there's not gonna be much data here. This just describes a single day. Okay, so these are the files. That's gonna be the URL we're going to use. So I'm gonna copy it, and let's just copy it as a comment here. So we keep it for later. And now with Wi-Fi manager, we can essentially connect and pass a callback that is going to be called when it is connected, or like when it's finished connecting, right? So it might be success, might be failure. There is a timeout we can specify, but let me just create the function on connect finished, and that's going to be just a simple function that we will pass here. And 5 seconds it's the default timeout, so it's going to try for 5 seconds, and I'm gonna keep 5 seconds, so that's fine. And when it is connected, what we want to do is to download the file itself, right? So to download the file, there is just a standard library, standard Arduino framework classes for ESP8266. So we need WiFiClient. Let me call it WiFiClient. And we need HTTP client, but I'm gonna need to include this. So ESP8266 HTTP client. And WiFiClient, I think, is already accessible. So that's gonna be HTTP client, and I'm gonna call it HTTP client. Okay, right. This is going to be pretty much based on an example from from Arduino IDE. The example is called, you can find it here on HTTP client, stream HTTP client. This is the one I've got opened. So it's going to be very similar to this one. There's even going to be a piece of code I'm going to copy paste later on. But yeah, let me just show you how to do it. So what we need to check first is if we can connect. So for that, you just need to call begin, and you need to pass WiFiClient. I think this, yeah, we can just do that. That is going to be WiFiClient though, WiFiClient. And the second one is going to be the URL, right? So that's the moment I need to pass the URL here. Right. I've put everything into an if statement because if it cannot connect, it is going to resolve to false. And then we can print some information like could not connect to the internet, maybe, because that would be essentially it. This happens when it cannot connect at all, and we just return. So that's gonna be it. It just stops, right? And otherwise, simply that's the positive scenario, right? We're going to get the code as the status code. Maybe I'm gonna call it status code. And that is going to be HTTP client and get method, right? We're using get like in the browser. So status code. Now additional check on the status code. So that is going to be code. When the code is less than 0, this happens when we have some device issues. So for that, what we can do is to, again, just print out the error message, and let's just say get failed, and error is S, which is going to be HTTP client get is it get? It's get error to string, right? Error to string, and then you pass the code, and that's gonna give you a string that we need to change to C string, and that's gonna tell us this is one of the errors. Like you see, you have like connection failed, send header failed, no stream, no HTTP server, this kind of stuff. So we print this information out and stop, right? Another check is going to be if code is different than HTTP code OK, which is 200, right? So if it's not 200, we want to say something like invalid status code, and let's just print this status code out. Code, right? And again return. So these are the negative scenarios. Hopefully they won't happen, right? Okay, and now finally we can read the response body, which is simply going to be something like simplest way, right? Very similar to the simplest example yesterday. What we need is to a body. This is gonna be a string, and you just do HTTP client get string. That's gonna read entire body and assign it to the body variable. And after that, we want to write it to the file. This is the moment where we want to, open the file. So little fs begin. We need to initialize the file system. Then we're going to open the file. So we need a file name, right? We need a file name. So you know what? I'm just going to again define some sort of variable, and just let's call it file name, and that's gonna be file maybe .txt. So that's gonna be our file name, and that's going to be the file we will open for write, right? We open it to write to it, and then we're going to get size t, I think it's bytes written, and that's file write, and we can simply write the body there, but C string, right? So that's what I'm gonna do. I think it returns size t. Yeah, let me confirm that it is size t. So if bytes written is 0, then again we want to say something like could not write to the file, and then return, right? That hopefully is not going to happen either. And once we've finished with writing, we want to close it, I mean the file, and we want to just finish the release the memory on the file system. Okay, so that's pretty much it when you want to write to the file. Okay, yeah, I've just realized I have an issue here. This is status code. So that should be status code everywhere. I don't know why I put code. Maybe this is because I tend to simplify everything as much as possible. So we've got this done, but I wouldn't say this is finished because we have no way to tell whether the file has been downloaded successfully. So what I'm going to do is to maybe let's use timer for that. It's a timeout when this process finishes, when we reach this line, so everything is correct and the file has been written. So I'm gonna define a function, and that function is gonna be called read file, right? Simple one, read file. And the reason I created it is because once this finishes, I would like to use the timer to set timeout and read the file then, right? And after 3 seconds, let's give it 3 seconds. It is not really required. You could read the file straight away, but it's just, you know, the use of the timer. Okay, and read file is going to be very similar to what I've done yesterday. Simplest example again. So we need little fs begin, then open it for reading, and we can just say content equals file read string. Right, let's read everything at once. We have a small file, we deal with small files, so we can just do that. And after that, I can simply print this out, right? I could even simplify this, to be honest. I can do that. I don't need a variable. So C string, right? And then file.close and little fs end. Okay, so let me just again quickly go through it. However, before I do that, one more thing I've just realized. In the loop function, I need to call the timer tick. I need to actually improve the timer class a little bit, so this is not a required step anymore, but not today. I might do it myself actually and just publish the changes to the library, core library GitHub. Cool. Okay, again, let's just quickly go through the code. So everything starts on the setup, right? We're trying to connect. If we manage to connect, then we try to connect. We try to download the file, right? And there is one more step that we need to do. So good that I've started going through the code again, because this is actually taking a callback that takes an argument, and that argument is a status. status. So this code would work if we assumed that we always gonna connect successfully, but this is not the case for me because I don't trust this is gonna happen, right? And you should not either. So let's make sure that the status is actually WL connected, and if it's not, let's just print out could not connect to Wi-Fi. Easy, right? And return. So that's the first condition. So now I think the code is complete. And again, we can go through it again. So Wi-Fi manager connect, when we manage to, when the process of connection is finished, this callback is being called. We check if we are not connected, and if we are not, that's it, we stop. Otherwise, we're creating Wi-Fi client, HTTP client. We begin our HTTP connection. If that fails, we stop. Otherwise, we setting the method to get, and we checking the status code. If it's less than 0, we just, return the error, stop. If it's different than okay, we do something similar, but with status code this time, not the error message. Then we read entire body at once using getString. Then we start our file system. We open the file for writing. With writing to the file, one check if the bytes has been written. If not, basically we stop. I've just realized when we stop, we should probably close the file and end. And otherwise, yeah, we still close the file and release the memory. And after that, we schedule a read file to be called in 3 seconds. And when this happens, this is very similar to yesterday. So that's just reading entire contents of the file at once and printing it to the serial monitor. Let me just add another line, so we'll see this, right? That's gonna be useful for the next step. Cool. So let me compile that. And I'm going to deploy it now. Okay, it is deployed, and I'm going to connect to the serial monitor now, and let's see what we get. We need to wait a little bit. Okay, file contents, and that's the file contents, right? So it was easy. It did download the file successfully. Cool, okay. And now what I'm gonna do is to try to download the bigger file with the same method. So essentially I'm going to change just this URL to a different one, which is the big txt file. It is quite long, right? And let me just replace that value with this value now. And I'm gonna deploy it again, and we'll see what happens. We should run out of memory, but I don't know how the device, how the ESP is going to behave, because there might be some safety mechanism put on the string object, on the string class, Arduino string class. So it might not crash. Okay, we've got a serial monitor, and let's see what's gonna happen. Could not write to the file. That's what we got. Could not write to the file. So it is this one, right? And the reason probably is that the body just was empty. It was empty because we ran out of memory. We tried to read entire file at once. We tried to read entire body at once. So for that, I'm gonna have to make a modification to my code. And that modification is going to be on the way we read from the body, right? Not the file, but the body. I mean, we also gonna change the way the file is written to. It's not gonna be a single, it's not gonna be like this single line writing everything. But yeah, let me show you. And I'm going to help myself with the example on Arduino IDE. That example is actually this one, right? So stream HTTP client, and what I'm interested in is this bit of code where we get the length and we read the file in a loop. So that's what I'm interested in. I'm gonna copy it and paste into my code, but this is gonna happen right after the initialization of the little fs. So here, and what is going to happen, yeah, we don't need this if-else statement because we're not reading at once. So we're gonna use the stream instead, because because the body, the request response body are streams essentially. Right, this is on top of TCP, and this is actually what's been done here, because I think WiFiClient is just a TCP client, and we read all the bytes from the TCP connection when we make the HTTP request. But yeah, let me show you how this is done. There is one modification I could do to that stream, which is simply instead of defining stream like that, what I could do is to, that should be, first of all, that should be HTTP client as well. So that's HTTP client, and we have, we're gonna have stream, but we don't need to do, I mean, that was also correct, but what I'm gonna do is to use the method here to get the stream pointer, right? So get stream pointer. I'm gonna have a look inside. Okay, that checks if it's connected, so it's better to keep it to first of all copy the pointer here. Okay, so we got the stream as a pointer here, and now we want to check if HTTP client is connected, and then there is some operations that needs to be done with the length itself. Apparently this is the best way to read the body as a string. One modification here is going to happen on this line, right? So instead of writing to serial, displaying a stream as it's read on fly, we want to just write it to the file. So this is where I'm gonna copy everything here, right? Instead of the serial, instead of writing to serial, essentially, we're going to write to the file. And what we're gonna write to the file? We're gonna write a buffer and C, which is the length of the number of bytes that we've managed to read from the body. And yeah, if we cannot write the bytes, then we're just going to finish everything. At the end, we close the file. We close the file system, and then we scheduling another function to happen, the read file. I have to modify it. So this is gonna be based on while now, and that is going to be while file available, because the file is big, so we cannot read it at once. And we know there are new lines, but I'm still gonna do it with the buffer. I just like it more. The file on the internet can always change, so this gives us more safety, maybe, I guess. Okay, let me define, maybe 64 is gonna be the buffer, and then I'm gonna do file.readBytes. And obviously we also need size t bytes read bytes and buffer, and the second one is going to be size of buffer -1 because it's a char, and essentially it's going to be const char, right? And this one additional thing, which is buff bytes read, is going to be the end of the string. And here I'm going to just print it. But not with the new line, just a buffer, right? Yeah, for reading from the file, have a look at the previous video. There are like 3 examples there, so you can have a look. And this one is the last one, right? There was other one with the reading line by line. Maybe I quickly go through the code again on this example. So it is pretty much everything is the same until, so yeah, we try to connect to Wi-Fi. When that process of connecting to Wi-Fi finishes, a callback is called, and we have the check if the status is connected, right? Only if it's connected we continue. Then we try to establish the HTTP connection. This time the URL is different, right? It points to the bigger file. If that is successful, we check in the status code. Only if it's 200, we start the operation of reading from the stream, from the body stream, and writing to the file. So we open the file to write. We get the size of the body. It might be -1. If it's -1, that means the size of the body is not known. That might continue for some time, right? So sometimes it's the case for the bigger files. So that code also handles that, right? The one from the Arduino IDE example. However, we still get this length. We initialize the buffer. This is a byte type. It's got 128 length, so that's the array of bytes. And then we get the stream pointer, the body stream pointer, right? This is how we're gonna read from the body, from the HTTP response body. Then we have this while loop that is gonna continue as long as we are connected, and the length is either greater than 0 or equals -1, right? If it's -1, just keep going, reading what's there. If it's greater than 0, we know that the length of the body is known. So having this operation here, where we subtract what we've managed to read from the stream, from the len, that's gonna go to 0. At some point it's gonna go to 0, and when it's 0, that's gonna exit, the code's gonna basically exit the loop, right? And here, this line, we read from the stream. This is important. That gives us the value that is the least value here, right? So if len is less than the size of buff, it's going to read the len number of bytes. Otherwise, it's gonna be the buff number of bytes, which is 128. The reason this is done is simply because we probably, at the very end, the last chunk that is read from the stream is going to be less than 128. And this handles that case, right? So that gives us the bytes left on the stream to be read. And if it's basically less than 128, that means this is the last chunk, and that's gonna be read from the stream. Additional check here is for the timeout, apparently, which is probably happening if we don't manage to read any of the byte, right? So maybe like if in between of reading the body, the connection drops. It might happen, right? So this probably handles that sort of situation. I can even return at this point, so we won't continue. Probably, yeah, that means that this is broken. Maybe it's gonna try again. I'm not sure actually what's gonna happen. Maybe there was a reason, there was timeout. So it's up to us. And maybe I keep it like that because it was in an example, but you can experiment with that and let me know in the comments if the return is good there on that line. And this is the code to write to the file, right? So we're writing the buff, right? The information, the bytes from buff, and this is the length of the buffer that we want to write to the file, right? That simply checks if that managed to write. And I've already talked about this line, which is basically subtracting the number of bytes read from the stream from the len. And then we close, we finish on the file system and set the read file to be called in 3 seconds. And that simply reads the file again, chunk by chunk, right? So we read bytes here and just display it on the screen, display it on the serial monitor. More information about this is in the last video, so you can have a look, link in the description. Cool. So yeah, one extra thing I forgot is to close the connection on HTTP. So HTTP client end has to be added here. However, it is not that bad if we just read one file, but it's always good to end the connection as well as we close the file, right? So don't forget about that. And that's pretty much it. Let's give it a go now. So I'm going to deploy. Okay, deployed, connected to serial monitor. And now we're reading the bytes. Yeah, that's gonna take a while because the file it is not very big, but I think it's a few hundreds kilobytes. Right, so that's been read, 3 seconds, and now we're getting the file itself. Yeah, that's gonna take a while because there's like 20 sections, I think, there on the HTTP specification. Okay, done. Let's just quickly have a look at this. So you see, we got this displayed nice way, right? Seems to be working perfectly. So yeah, this is how you essentially download bigger files over HTTP, right? Bear in mind, it's just HTTP. This is not gonna work with HTTPS. And this is it for today. Thanks for watching. Tomorrow I'm gonna be doing the same thing, but over HTTPS, a secure protocol instead, which is actually the recommended way, especially when you're building IoT device, although it is a bit more complex. If you like the video and you want to stay up to date with my channel, I suggest hitting the subscribe button so you will get notified as soon as I upload a video to my channel. See you tomorrow!